Hello, my name is Shannon Chance, and it is my great honor to speak with you today on the topic of equipping STEM graduates for global challenges via design thinking. Thank you very much to the Chinese Society for Engineering Education for inviting me to be part of this very important international symposium about how to innovate the world's engineering education systems to support global challenges. I am speaking with you today from Technological University Dublin in Ireland, where I am a lecturer and program chair in BIM digital construction. I am also a visiting professor at University College London in the Centre for Engineering Education. As the overall symposium focuses on global challenges and on creating education systems to help address them, the specific focus that I'm bringing today is on design. I believe that design education that immerses students in understanding and seeking to resolve complex real-life problems, particularly in real-world community settings, is an important and underutilized way to engage students in these issues and help them learn. Today, I want to talk about the power of design to empower students and build the values, skills, and knowledge they need to go into the world and facilitate the types of change humanity desperately needs. One specific technique I am promoting to build skills, understanding, and ability in students is service learning, also known as community engagement. This is where students address local problems existing in communities and work with individuals in the community to help build their communication skills and the students' ability to navigate their way through complex problems and contexts. Another specific technique I am promoting is design-based learning. In engineering, we use the term problem-based learning to signify solving all sorts of problems. To me, what is important is that students learn to analyze and respond effectively to ill-structured, open-ended problems in complex contexts. It is crucial that students learn to frame problems as well as to solve them. Design-based assignments need to build foundational skills in the early years and then increase the complexity of the problems as students matriculate through the undergraduate curriculum. I taught architecture in the United States for over 15 years, often conducting programs in other parts of the world with my students. And we were able to witness the power of environmentally and socially sustainable design to activate students' consciousness and help them feel motivated to achieve change and confidence in their abilities to understand a wide array of factors operating at various scales. It is crucial that students graduate from university able to see patterns at various scales and relationships between them. Design education helps students see that each decision impacts every other decision and that iteration is both positive and necessary in making decisions. Design education helps students see connections between the physical artifacts they, as engineers and architects, bring into the world and the people and the natural environment both around them locally and at a more global scale. So what does this type of education look like, and how can it be geared toward tackling global challenges? I will provide specific examples from architecture and education courses I have taught, and then discuss prominent examples from engineering as well. My hope is to provide you inspiration to implement design exercises from big to small into the modules you teach and the curricula you lead. In the early 2000s, I designed a module for second-year architecture students at Hampton University in Virginia, United States. We called it architectural ecology, as this was before sustainability became the buzzword. This module met for 3 hours per week, and it was designed to foster students' knowledge about sustainability issues related to their profession. It also fostered their basic skills with regard to sustainable design, and it sought to impact their values, particularly their sense of necessity and urgency for implementing sustainable solutions. First, to build knowledge about sustainability, the course involved lectures and readings on technical aspects of design, such as heat transfer, insulation values, thermal convection currents, and passive solar systems. thermal convection currents, and passive solar systems. Second, to build skills in sustainability, the students completed 3 projects, all of which directly informed the design projects they were undertaking in Architecture Studio, which they were completing in parallel with architectural ecology. The 3 projects also involved specific real-life sites that the students could visit multiple times over the course of the project. Some of these were natural and some were urban. This helped them begin to understand relationships between various aspects or factors on the site and at various scales. The 3 skill-building projects involved, first, a detailed analysis of a specific site they were designing for, and then second, the one you see here, sun angle projections for a site they were also designing for. The third project was a presentation of research they had done on sustainable materials that could be utilized in a design project. Third, to build values in sustainability, we read theory, including seminal works like the book Cradle to Cradle, Remaking the Way We Make Things by American architect William McDonough and German chemist Michael Braungart. This overall approach proved highly effective at developing students' skills and abilities, and, equally crucial, their sense of ownership and responsibility for enacting environmentally and socially sustainable approaches in their design work. I say environmentally and socially sustainable approaches because we did focus on the built, natural, and social contexts. We used McDonough and Braungart's framework to balance decisions regarding the economy and those related to ecology and equity. The foundational skills and ways of thinking the students learned in the architectural ecology module were made more vivid and more memorable because the students applied these foundations in their iterative and intensive design studios, so they kept working with them, thinking about them, and applying them in different ways. The studio module met 10 hours per week and required extensive work out of class. There was a lot of hands-on engagement, application of concepts, and integration of concepts into their designs. By applying theory and iterating based on the specific context, they achieved synthesis. The approach paid off, and in subsequent years, they were able to implement such techniques when designing for increasingly complex situations and working with community groups to solve real-life problems. The teachers in the architecture department observed multiple benefits. Students embraced, increasingly over the years, the call to address environmental and social sustainability. In their 5th and final year in the architectural degree coursework, they self-select a thesis topic, and over the years, the number of students choosing environmental and social sustainability topics for their theses skyrocketed. It was clear that they embraced global challenges and found them very interesting and worthy of their attention. This 3-pronged approach to building knowledge, skills, and values, and applying these via design is easy to transfer to other situations and other degree majors. On 3 separate summers, I conducted a course at a different university, the College of William and Mary in Virginia, for students working to earn master's and doctoral degrees in the field of education. This optional elective module was called Educational Planning for Environmental Sustainability. Students in this course were intending to become academic leaders. We built knowledge of how to implement sustainability measures on college campuses by reading books and articles. We built skills wherein each student identified a particular problem to be solved on campus and conducted research and designed a program or a plan to address it on our campus. We took a number of field trips in this course, but we also used iterative peer feedback while we were making our proposals to help students learn to evaluate and constructively critique each other's work. These were not skills these students arrived in this education class having, and they were initially reticent to critique each other, unlike architecture students who had cultivated this ability over the years. Learning to synthesize, evaluate, and critique are essential skills for students to learn so they can address global challenges after they leave school. I'm happy to report that several of the student proposals were actually implemented. For instance, the students pictured here worked with dining services to help develop more sustainable systems for packaging and delivering food. Their work was featured in the university newspaper, and their proposals, which were created with input from the university dining managers also shown, were adopted by dining services. Now, so far, I've shown you examples of design thinking from architecture and education students, but examples from engineering are equally inspiring. For instance, one very comprehensive approach was tested over 3 years at the University of Michigan via a grant to support multidisciplinary team teaching. I did not teach the Smart Surfaces course myself, but I did analysis of it afterwards, aided by one of the 3 module leaders. Smart Surfaces was an elective optional design studio that ran for 3 years, where the student teams took a technical approach to solving design problems. The student teams had 6 members each, with 2 coming from material science engineering. The student teams had 6 members each, with 2 members coming from material science engineering, 2 from art and design, and 2 from architecture. I observed this module closely by analyzing the detailed blogs that students produced about the process and their reflections on it. In the first year the module was offered, students were asked to design a heliotropic smart surface. The second year, it was a biomimetic smart surface. And by the third year, they took a more community-based approach and asked the students to design a powerhouse smart surface for a family in Detroit. I hope that it's clear from the titles of these projects that a major aspect of this class was about framing the problem. What does it mean to make a biomimetic surface that is smart? For these students, it meant a surface, such as a wall or a floor, that responds to a biological input, such as a person or a house pet walking by. Results are available for you to view on the website smartsurfaces.net. The design process and products are documented in the students' blogs that are linked from that site. The students had access to vast machine shops, and they were supported in the use of sensors, code, electromechanics, and Arduinos. In the papers that I published with John Marshall and colleagues, I researched overlaps in students' maturation in design thinking with breakthroughs they described in their blogs that had to do with changes in their epistemological development, how their way of thinking about the world and about design and about creating things changed because of their immersion in this course. Benefits that I observed ranged from students being able to communicate and work effectively across disciplines to learning drastically different skills from their home majors and being able to integrate the new knowledge and see in dramatically different ways that each of these 3 disciplines embodied. So art and design, material science engineering, and architecture all have very different ways of thinking about things and prioritizing things, and they became familiar with talking to people in those languages. The engineers were more familiar with technologies, whereas other students had more familiarity and comfort with the design process itself. I was specifically looking at the development of design thinking skills and assessing it using an informed design matrix that was developed by David Chrismond and Robin Adams. I was also looking for any shifts in the way the students viewed knowledge and about the way they think about making new knowledge. So I was using the epistemological development schema that was created by William Perry in the 1970s. It was inspiring to find quotes in the blogs that showed the students had made shifts in their thinking from dualistic right-wrong ways of looking at the world to more contextualized approaches. I believe that design can help students understand that most issues they face in the world do not have one clear right and one clear wrong answer. That the quality of the decision has to do with its relevance and its applicability as the issue is situated in complex contexts. And often the context has many multiple moving parts, so they need to situate their thinking within that context to come up with the best answer. I believe that design education helps students transform from being receivers of knowledge who memorize and regurgitate facts to people who can determine for themselves what is right and wrong and generate new knowledge. They can define knowledge and truth. These are basic components of Perry's theory, and I found some evidence that the Smart Surfaces module was helping students work in complex contexts and see themselves as effective in navigating such complexities. For those who are looking for effective approaches to implement design and engineering, I encourage visiting smartsurfaces.net, the About page on the website, and also reviewing a recent report about a more prominent example, one from University College London, or UCL. At UCL, a comprehensive approach was implemented called the Integrated Engineering Program, or IEP. It has been documented in a set of case studies by Ruth Graham that was published by MIT Press. In the Integrated Engineering Program, students receive instruction in design processes and teamwork in their first year. They undertake a number of design projects called scenarios, where they draw from technical knowledge that they are developing in their engineering modules and synthesize it into a design response that they create in teams. They are also presented with significant challenges that last for multiple weeks or even a semester in a module called How to Change the World. UCL provides an example of dramatic transformation of an engineering curriculum, and I'm honored to have been able to conduct research there as a member of the Center for Engineering Education since the year 2017. At that time, I received a grant from the European Commission that allowed me to work at UCL full-time for 2 years. I'm an associate of the center still today as a visiting professor, and I encourage you to consider grants and fellowships that can give you the time and access to exemplary examples like UCL. Previous fellowships permitted me to go to Technological University Dublin, where I was able to witness and track progress of student development by conducting educational research. TU Dublin provides a valuable example of transformation of engineering curricula as well. They've done this on a program basis. I've been part of TU Dublin since 2012 and observed the transformation from a traditional lecture-based program that included lots of practical hands-on training nonetheless, into what is today a more design-based program where students learn to work in groups. Philosophies and pedagogies of problem-based learning now permeate the Bachelor of Engineering course. The 4-year honors level B-Eng course now begins with a Common Core first year, wherein students take foundational coursework as well as a series of 3 group-based design projects. They do all of this before deciding which stream of engineering they will go for their specific major. I've had the pleasure of co-teaching on all 3 of these design modules and helping student teams learn to design and build autonomous robots, model bridges, and energy-efficient buildings and space capsules. In the years starting since 2014, the first time we offered this course, I interviewed the entire population of female students from that first cohort. So the first cohort I talked with when they were in first year taking the Common Core, and then I interviewed them again longitudinally over 4 years until they graduated. I wanted to find out what the experience was like for them of learning collaboratively with others. Learning the ways of working, which included design-based and team-based learning. These are promoted at TU Dublin, but they took the students some time to adjust to. The adjustment was greatest for the third of the female cohort who had come to us from the Middle East. Like other students, the women from the Middle East had to learn to navigate the hands-on approach and also working on teams. But unlike other students, they also had to learn specific terms in a new language and to learn to understand Irish accents and word patterns, and most markedly to work on teams with boys. As they had never taken courses with boys or socialized with any boys outside their immediate families, this presented a significant challenge. Nevertheless, they were determined to learn to work in mixed gender, mixed ethnicity groups and to conquer complex challenges. They all said they would need to do this when they went to work in engineering in their home countries of Kuwait and Oman. For them, group-based, problem-based learning was a primary catalyst for their development. By 4th year, they were comfortable working on teams with male students, even when they were the only woman or the only foreign national on the team. Many of them had completed internships in industry during their degree programs and told me how they effectively contributed in ways to the companies where they were working that they had envisioned before they went. Their narratives were inspiring, and the narratives highlighted to me the power of collaborative PBL. Those first-year design projects set the tone and established their conceptions of the overall course as interactive and collaborative. My overall goal as an educator and researcher is to find ways to draw the best from architectural education and engineering education and to recombine these and to promote the most effective techniques for wide-scale implementation. In my opinion, architecture education excels at getting students to engage passionately and wholeheartedly in designing solutions with complex contexts. I believe that engineering education has succeeded in shifting the focus from the delivery of content to the actual learning that is going on. I believe that it is very student-focused. The student-centered focus has a different flavor in engineering education than in architecture. In architecture, the flair of the final project is overly prized. Although the architectural education system has many benefits, the well-being of the students is not the focus of enough energy, I'd say, and the profession's obsession with the look of the final result has resulted in overworked, underpaid professionals who do not always prioritize environmental and social sustainability, even though their educational format typically prepares them to do just that. In engineering, the problem remains today that students too often encounter a fragmented approach where the content is simply delivered at them. Whether they understand and can apply it effectively is often overlooked in the way lectures are delivered and examinations are conducted. Even a test, I think, can be an opportunity to lock important concepts into place for a student. It need not be a simplistic exercise in regurgitation or in the replication of calculation processes. It can really be a learning experience, not just an exam. And so, still today, I am interested in looking at engineering knowledge, engineering epistemologies, and engineering skills. Currently, I'm working on 3 projects relevant to what I have presented. In the first of these endeavors, my PhD student is working to develop models of creativity to achieve sustainability in various realms of engineering. We want to help move industry from traditional resource extraction models to more generative and indeed regenerative processes of design. The models Thomas is creating can help improve product design, engineering, and the overall sector of architecture, engineering, and construction. Secondly, I'm engaged in the design of an architectural engineering curriculum for a new university in Cairo. This curriculum will draw together highly effective pedagogies for teaching architecture and engineering and will also build on UCL's integrated approach to teaching engineering. Finally, I'm analyzing interviews I conducted with 26 students who are studying architecture and civil engineering, I should say, across 3 countries because I want to understand how they conceptualize design creation and the generation of new knowledge. I want to be able to compare the way architecture students and civil engineering students think, and I talked with second-year and fourth-year students in each major. I hope that all these activities together will give me better insight into how design education can be used to enhance the capabilities of students, individually and collectively, to address global challenges. So thank you very much for listening today and attending this presentation. I welcome your questions and comments, and I ask you to either submit them to me now or send them by email to one of the addresses on the screen. Thanks so much.